Hi everybody, welcome to this first session, first lesson in the series called Decoding Algebra. In today's session, we're going to learn about polynomials and expressions. It's one of the easier topics from algebra, but a very important one nonetheless, because pretty much every single exam will have a few questions coming up from this topic. Dealing with expressions. Right, let me tell you quickly about myself. My name is Anand Venkatesan. I'm your educator for today. Briefly about my background, I've done my engineering from VIT Vellore and then did my postgrad from IIM Bangalore. I have a decade's worth of experience in having trained students for the quant and verbal sections of the CAT. Well, I've scored 99 percentile many times, but the most recent one was 2 years back, CAT 2018, in which I scored a 99.55. And I'm one of these, this beautiful team of educators at Unacademy. I think we take pride in the fact that we know the subject matter and we create value online. I think it becomes fairly easy to learn online, with an app that's as beautiful as functionally nice as Unacademy. Here's the agenda for today's session. We're going to deal with, since this is the first session on algebra, I'll set up some context. I'll talk about the basic terms, the basics of algebra in a sense. But I'll then move on to, the remainder theorem, which is one of, which is our crux for today's main topic. And finally, we'll also get with, deal with solving polynomials and expressions by using algebraic identities, right? So those three modules we learned today. Well, if you like this session, do make sure that you join us on our channel. Obviously, CAT4MBA is the channel that Unacademy has on YouTube. But we also have a Telegram channel where, we'll keep dropping all, lesson links. We'll drop all material and tons of other helpful, useful things on Telegram. Right? I've also sort of marked out my Telegram channel. That's Anand for Quant. So do follow me there to make sure that you keep yourself updated with all all the lectures and all the fun that I'm going to involve you with. There are obviously many subscription plans on Unacademy. What we do here is more like a revision or talking about the main highlights of the topic. But if you want to learn in earnest, you want to start learning as a batch, then you need a valid plus subscription on the Unacademy app. You can see that on your tablet or your mobile phone. If you download the app and you look at the subscription plans, there are many options available. The ones that I've highlighted are the ones that I would really recommend you to consider, because if you're looking at CAT 2021, next year's CAT, and you're starting up right now, chances are you need at least a year's worth of preparation, maybe even more than that, because you don't just target CAT, right? You target all other management exams. So and when you do subscribe, make sure that you use my referral code, that's AV01, because that gives you a 10% discount, right? Avail of that. Right, on to today's agenda, right? We'll deal with polynomials and expressions, and I'll begin with a quick run through of the basic terms of the basics of algebra in a sense, right? What exactly is algebra? Well, algebra is nothing but the study of unknowns, right? In a sense, the word algebra actually is related to dealing with unknown values, right? Sometimes when you're dealing with a puzzle or you're pondering a question in your mind, then whatever you sort of picture in your mind, when you start putting those down, then the branch of mathematics that helps you do that is called algebra, right? And so these unknowns, when you're trying to go from unstructured thoughts to structured mathematical equations or expressions, then algebra has some basic tools, right? We will use variables, right? Anything which is unknown, anything which I need to determine will be assigned a variable, a letter or a character that denotes it. We'll use this to form equations along with constants, right? Constants are fixed values, things that are unchanging. You might be traveling a certain distance, that remains unchanged. You might start off with a certain number of chocolates in your bag, that remains unchanged, right? So those are constants. also important to my problem, right, to my situation. But variables and constants are always combined, and so we also have something called a coefficient, right? So when you combine variables and constants, you create something called a term, and in a term you will have a combination of variables and constants, right? So anything that comes before the variable, anything that gets multiplied with the variable or a power of the variable is called its coefficient, right? So if I consider a a term like 5x, then the coefficient is 5, right? If it's a term like 15x cube, then coefficient is 15. Or if I say minus 1 by 3 y power 4, then the coefficient is minus 1 by 3, right? Okay, fair enough. Whatever comes with the variable in the expression that I have is called the coefficient. Okay. If you consider many such terms and you combine them, you create something called an expression, right? An expression basically contains one or more terms, and each term will contain variables and constants, or maybe one of them only, right? But an expression will contain many such terms, right? And when you take an expression, you could also call it a polynomial if it has at least two terms, right? So anything that has, at least three terms. Anything that has more than two terms in an expression, then that expression is called a polynomial. You can see that it comes from the word poly, which stands for many, right? The word root stands for many. So polynomial. Okay. How is a polynomial different from an equation? It's one of those classic things that come up every now and then. People still tend to get confused with this. A polynomial is simply an expression, right? Which means if you substitute values within the variables, you'll get a value, right? But an equation will have two expressions, and there will be the equal to sign, right? In fact, equation is, in a sense, the word itself comes from equality, right? Equa. So equation is something which equates two expressions or two polynomials, right? So when I take two expressions and equate them, I'll get an equation, right? Now I can, whether it's a polynomial or an equation, I can define something called a degree, right? I can describe the polynomial or the equation. Very useful way of describing it is to call out its degree. What is the degree? Well, degree is the highest cumulative power amongst, when considering all terms in an expression or an equation. So let's say I have an expression that has 5 terms. You go term by term, and in every term you'll consider the highest power, cumulative power of variables. When I say cumulative, I mean you add powers of, if you have more than one variable within a term, you add their powers. So for example, if I have a term that says 3xy, then I'll add the power of x and y, which means this is a degree 2 expression or degree 2 term, right? But to this term, if I add 5x cube minus 9xy to the power 4, then I'll know this has a degree of 3 because x cube. But this one, adding powers of x and y is a degree 5 expression, right? So, and now once I've worked with multiple terms, you consider the term that has the highest degree and report that value, right? So clearly the highest degree amongst all the terms is 5. So that's the degree of this expression, right? Fairly simple, isn't it? But why is the degree useful, right? Well, degree actually puts an upper cap on something called the root, right? On the number of roots that exist. But for that, we'll also need to understand what a root is. So what exactly is a root? A root is the value of the unknown variable that you've considered, x, y, z, etc. So x, y, z, whatever value you substitute, that makes the left hand side and right hand side of the equation equal, right? They're supposed to be equal, right? You have an expression on the left, you have an expression on the right, maybe a constant on the right, maybe even 0 on the right. But what value of x or y or z when substituted makes the two equal is called a root, right? So essentially a root is that value of the variable or variables that satisfies the equation, right? A root will satisfy an equation, right? And so what that means is that if I'm given a root, I can substitute in and ensure that it makes the left hand side and right hand side equal, right? Okay. So that's a root. And what does the degree do? It puts an upper cap on the number of possible roots. So if I have a degree 5 expression, then a degree 5 expression in a single variable, right? If I have only one unknown variable x and I know the degree of my equation is 5, then I'll know I cannot have more than 5 roots. I can't have more than 5 possible values of x that satisfy this given equation, right? So it puts an upper cap on it, right? But all this while we were talking about equations, right? Where you had a left hand side, you had a right hand side to check. But what if you have just an expression? What if you have just a polynomial? Clearly, you can't substitute in a polynomial. If you substitute the value of x in a polynomial, you don't have anything to compare it with, right? So then there is no question of it satisfying, the polynomial. But what it can do is it can make the polynomial 0. It can make the expression equal to 0. And so when substituted, if a value makes the expression 0, that substitution is called, that substituted value is called the 0 of that polynomial, right? So a polynomial has zeros. A polynomial will have zeros, but an equation will have roots. And both of these are limited by the degree of that expression, degree of that equation. If the degree is known, then that puts an upper cap on how many solutions or how many variables there can be. Solutions there can be, or roots or zeros there can be, right? I hope that makes sense, right? Just give me a minute, guys. I will continue this. Right. Deepika, hi. I just saw your text. Class हमेशा यार इसी time पे हुआ करेगी. I'll be joining you guys at 8 o'clock. The schedule for the coming next few days, I will share it on my Telegram channel. That's Anand for Quant on Telegram, right? So make sure that you check it out there. Right. Now that we've learned the basics of algebra, let's get into what is called the remainder theorem, right? So there's something called the remainder theorem. What does the remainder theorem say? Well, remainder theorem applies to a polynomial, right? But I already know a polynomial is an expression which has many terms, and I also know that the degree limits the number of zeros for a polynomial, or maybe the zeros or the roots of an equation. But what exactly does the remainder theorem do, right? The remainder theorem also deals with polynomials. What it does is that remainder theorem says that if I consider a polynomial f of x, now this itself is a gray area, right? Why am I calling a polynomial f of x? Well, some of you will probably think this is called a function, right? But what exactly is a function? Function says that the expression depends on x. So any polynomial will inherently be a function, isn't it? So, but all functions will not be polynomials. So any polynomial f of x, I can define it. I can call a polynomial as f of x. It is a function in x. So if I take a polynomial which is an expression in x and I want to divide it by a linear expression x minus a, right? So I want to divide it by x minus a. Remember here x is the variable, unknown variable, but a is a constant, right? A is not a variable. A will be a constant like 1, 2, 3, positive or negative, right? What does the remainder theorem say? It says that if you are dividing by x minus a, take the value of a and substitute it in the expression itself instead of x. Take a and replace x with a in the given polynomial, in the given expression, and the resulting value that you get will be its remainder, will be the remainder of that equation, right? You want to test it out? Let's consider an example, right? So say you want to divide x cube plus 5x square minus 9 by x minus 2, right? First of all, let's do the division, right? I hope you guys remember your division of polynomials, x cube plus 5x square minus 9. If you divide it by x minus 2, right? The process goes something like this. I first want to multiply x with something to make it x cube. Clearly that's going to be x square. So x into x square will be x cube, but minus 2 into x square will be minus 2x square, right? Next step, reverse the signs and x cube minus x cube will become 0. 5x square plus 2x square will become 7x square. So I'll have 7x square minus 9. So if I want to make 7x square, x should be multiplied with plus 7x, right? That will give me x into 7x, 7x square. It will also give me minus 2 into 7x as minus 14x, correct? Now reverse their signs, right? What will happen? 14x minus 9 is what I get. So if I want to make 14x, I'll multiply x with plus 14. And if I do that, I'll get 14x minus 28. On reversing the signs, 28 minus 9 gives me 19, right? So here I know the remainder here is 19, correct? But can I use the remainder theorem? Remainder theorem says remainder should be equal to f of a. What is a here? So if you consider x minus 2 and you say, okay, we were supposed to divide by x minus a. In this case, that is x minus 2. Clearly, this suggests that a will be 2, right? And if a is 2, the remainder should be f of a, which means that should be f of 2, right? What should I do? Consider the expression given over here, x cube plus 5x square minus 9, and replace x with 2. So 2 cube plus 5 into 2 square minus 9. Does that give me the required remainder? 2 cube is 8, 5 into 4 is 20, minus 9. So 28 minus 9 is indeed 19. That's exactly what we got in the result of the division, right? I hope that sort of clears up how remainder theorem works, that it does indeed work in fact, right? So if I want the remainder directly, all I need to do is substitute, first figure out what the value of a is going to be, substitute that value of a in the given polynomial, in the given expression. Okay, now this would be all well and nice if this was a direct question in the exam, right? Are you gonna get, do you expect in an MBA entrance exam like CAT or IFT or ZAT, should we be expecting questions on find the remainder? No, absolutely not. You wish this was a question in the exam. Unfortunately, no. So what kind of a question, what kind of a problem will I then use? Remainder theorem. The answer is you don't usually use remainder theorem. You use a derivative, or what is called in math as a corollary of the remainder theorem, which, let's understand, this is called the factor theorem, right? What is the factor theorem? Well, factor theorem just, sort of rephrases the remainder theorem into a more usable form for us. What does the factor theorem say? It says that for an expression x minus a to be a factor for a polynomial fx, all it needs to do is satisfy f of a equal to 0. Now what was f of a? In remainder theorem, f of a was the remainder, right? So this basically says for this to be a factor, the remainder should be 0, right? That is intuitively, that's obvious, right? I hope that it is obvious to you, right? But why is this useful then, right? Why is this useful at all for me? Well, the answer is that whenever you're dealing with algebra, right? In algebra, we will deal with linear equations or linear expressions. We might deal with quadratic expressions. Remember, linear is degree 1, right? Quadratic is degree 2. But we could also have cubic or higher order polynomials, right? Which would be degree 3, degree 4 and so on and so forth. So the thing is that in general, we learn how to solve linear and quadratic equations. But there is no set approach for a cubic or in fact a degree 4 equation, right? There are no standard methods that you can use, right? What you will use is the factor theorem, right? So when will I use the factor theorem? Degree 3, a cubic equation, or higher degree or higher order polynomials, right? If you get higher order polynomials or equations that have degree 3 or higher, use factor theorem. Remind yourself to use the factor theorem. How do I use it? Well, consider that I want to factorize an equation, an expression that looks like this: x cube plus 4x square plus 4x plus 1. Let's say I want to factorize it. I know it's a cubic equation, cubic expression, but I don't know how to factorize it. So what I'll do is I'll consider this as f of x, right? Now to factorize it, I want a factor, right? And when is x minus a factor? When it makes this expression 0. So what will I do now? I will perform a process of hit and trial. I will try and substitute values of x in this expression and try to make it 0, right? Okay, let me try. Let's say I put x as 1. What is f of 1? 1 plus 4 plus 4 plus 1. Okay, this was a terrible idea. I'm getting 10. But more importantly, I noticed that all 4 terms are positive. There is no way it will become 0 if you have 4 positive values getting added, right? So clearly we want negative values. So let me try minus 1. What is minus 1 cube? That's going to be minus 1. 4 into minus 1 square. Minus 1 square is plus 1. So this becomes plus 4. But 4 into minus 1 will be minus 4. And I obviously will get plus 1. So what do you see? 4 and minus 4 will knock off. Minus 1 and plus 1 will get knocked off. Which means this becomes 0. Right? And the moment you get f of a is equal to 0, you will conclude that x minus a is a factor. Right? This means x minus, what was a? What did I substitute? Minus 1. So x minus that will be a factor. Right? So there you go. We've successfully considered a cubic expression and found a factor for it. X plus 1 is indeed that factor. Right? Now that I know a factor, you can generate the other factor by dividing the original polynomial with x plus 1. Right? If you do the division, you will get a second factor. How this is how I do it though. Right? I'll write x plus 1 and I'll say, okay, I want the other factor, right? But let me write on top what I want, x cube plus 4x square plus 4x plus 1, right? This is what I want to finish with. Okay, so with x I want to make x cube, clearly I should multiply with x square, okay? But as a consequence, this will make x cube, but it will also make x square. But I know that comparing with the original expression, I know I want 4x square. I've only gotten 1x square here, which means I'm missing 3x square. So now I want, next step, I want to make 3x square. How do I make 3x square? Multiply x with 3x. There you go. X into 3x will give me 3x square, but then it will also give me 3x. Right? So there you go. We made x cube. We made x square plus 3x square equal to 4x square. But now when we wanting to make 4x, I've only gotten to 3x, right? Which means I'm missing 1x. How do I make that 1x? Multiply x with 1. Right? What will that give me? X into 1 is x. 1 into 1 will be 1. Right? So here is what I end up with, x cube plus 4x square plus 4x plus 1. Exactly the original expression. And so now you can see that I have a first factor from factor theorem. But then, checking out what the other factor would be, right? Either I divide or I simulate, the division in a multiplication format, right? Either ways, that will give me a quadratic expression. And the moment I know it's a quadratic expression, use, whatever we will learn in the next few lectures about quadratics can be used here to factorize, right? So that's how you proceed with factor theorem. We use factor theorem in a question that involves higher order polynomials, degree 3 or degree 4 equations or polynomials, right? Consider this example. Let's say I want to find the remainder when x power 4, in fact the longest expression. What happens when this expression is divided by x plus 2, right? Now, usually remainder theorem applies when you're dividing it by x minus a. So equate x minus a with x plus 2 and say, okay, let's find out what a is, right? X will go away. I'll get a as minus 2. Okay. But we want the remainder. Remainder theorem says remainder will be equal to f of a, which means this should be equal to f of minus 2, right? Let's take minus 2 and substitute it for x over here. F of minus 2 would in fact be minus 2 to the power 4, that's 16. 5 into minus 2 cube, that's minus 8. So 5 into minus 8 is minus 40. 3 into 4 is 12, so minus 12. 4 into minus 2 is minus 8 plus 3. Right? What do I get? 16 plus 3, 19. And adding all the negatives, 40 plus 20 is 60. So 19 minus 60, I'm getting minus 41. So the required remainder in this particular problem is minus 41. Right? And I hope you guys find it as easy as it actually is. Right. That previous question was never going to come in the exam, right? Instead, this kind of a question uses our understanding of factors and roots, right? What you know is that if a polynomial, this expression, you can see that it's a degree 4 polynomial, but it has 3 constants which are unknown. A, B and C, all 3 are unknown, right? But when this polynomial is divided by x minus 1, I know that the remainder is given as 4, right? So first division, I know remainder is equal to 4, but I know remainder should be f of a. Here x minus 1 I can see that a will be 1. So f of 1 will be 4, that's given. And secondly, when I'm dividing it by x plus 1, the remainder should be equal to f of a, that's f of minus 1. Remember, x plus 1 can be written as x minus 1, x minus a, where a is minus 1. So f of a, that's f of minus 1, should be equal to the remainder, which is 3, right? So I'm given two conditions here, f of 1 is 4, f of minus 1 is 3. Let's substitute f of 1, right? Substitute 1 instead of x. That will give me 1 plus a minus b plus c plus 8 equals 4, right? Which means a minus b plus c will be, if you take 9 on the other side, it will become minus 5. Alright. Let's put let's calculate f of minus 1, substituting x as minus 1. I'll now get 1 minus a minus b minus c plus 8 equals 3, right? So now I have a plus b plus c, right? You can actually take it to the other side, will be 9 minus 3. That's going to be 6. So you have a plus b plus c as 6 and a minus b plus c as minus 5. If you read the question, we want to find the value of b, right? So if you want b, you want to eliminate a and c, and you can see a and c can be eliminated by subtracting these equations, right? So just subtract 2 from 1, right? So if you subtract a plus b plus c minus a minus b plus c, this should then be equal to 6 minus minus 5. Let's see if that works out. A and minus a will get knocked off. C and minus c will also get knocked off, right? But b plus b will become 2b. So if 2b is equal to 11, b will in fact be 11 by 2, right? So in this question, 11 by 2 or 5.5 is the required value of b, right? 5.5. I hope that makes sense to you. Alright, here's another one. 6x cubed plus 19x squared plus 2x minus 3 is given to me as k times this expression, right? The question says find the value of k plus a into b into c. Yeah, let me give you a minute to think about this, right? This is a cubic equation, yes, which means it should have at most 3 factors. I can see it has 3 factors: x plus a, x plus b, x plus c. A, b and c are constants, right? And this is also multiplied with k, right? First thought, x cubed, the coefficient of x cubed here will be k, right? So k is equal to 6. That's the first thought. I know the value of k. But how do I find the value of a into b into c? Which means how do I find the value of a, b and c, right? So for that, you start with the left hand side. First of all, you think, okay, even if nothing else is known, I know that I have a polynomial f of x, which is 6x cubed plus 19x squared plus 2x minus 3, right? So why not just factorize it, right? So to factorize, I need to do a little bit of hit and trial, right? Now notice that all coefficients of x's except for the constant term, all of the other terms are positive coefficients, which means if you put a positive value of x, it will give you positive value for the expression, right? Each term. But you don't want positive, right? You want it to become 0, which means you also want negative values. So let me put minus 1, right? So let's say f of minus 1. What will happen? You'll get minus 6 plus 19 minus 2 minus 3, right? That's not 0. Clearly not 0. What about minus 2? F of minus 2. 6 into minus 8 is minus 48. This is 19 into 4, 76. This is 2 into minus 2, that's minus 4. And that's minus 3, right? That's also not 0. Okay, how about minus 3? 6 into minus 3 cubed, that's 27. So 6 into minus 27, that's minus 162. Plus 19 into plus 9, 19 nines are 171. 2 into minus 3 is minus 6 and minus 3, right? 6 plus 3 is 9, 162 plus 9 is 171. So I'll end up getting 171 minus 171, which is clearly 0. And the moment I get f of a 0, I will conclude that x, x minus a, that's x minus minus 3, which means that is x plus 3 is a factor. Right? Now the moment I have one factor, I can generate the other one, right? Let me quickly do that. X plus 3 into, so to make 6x cubed, I'll now multiply with 6x square. That will give me 6x square plus 6 into 3, 18x cubed. Sorry, 6x cubed plus 18x square but I want 19x square, which means I want one more x square, multiply x with x, that will give me x square, but that will also give me 3x. Okay, do I want 3x? No, I want 2x, which means I want to reduce an x. So multiply x with minus 1, right? That will give me minus x minus 3, right? And x, will reduce, but you'll end up getting plus 2x minus 3, right? So there you go. These are going to be your two factors, x plus 3 and 6x square plus x minus 1. 6x square plus x minus 1 can also be further factorized into 2x, sorry about the typo there. Alright, here we go. Right, 6x square. So I'm going to write this as x plus 3 into 6x square plus x minus 1 can be written as 2x plus 1 into 3x minus 1. Right? We will, discuss quadratic and how to factorize it. But for now, assume that you either remember it or assume that these are indeed the factors, right? 6x square plus x minus 1, right? Now, if you compare this with the original expression, you'll see x plus a can correspond to x plus 3, but x plus b has coefficient of x as 1, right? Now, I want to make this as 1, so I can take the 2 common from here, 3 common from there, they'll get multiplied and become 6, which means this will become 6 into x plus 3 into x plus 1 by 2 into x minus 1 by 3. I don't know what's wrong with my pen, but I hope you are following, right? So which basically means that a will be equal to 3, b would be equal to minus 1 by 2, and c would in fact be equal to plus 1 by 3, right? So if the question asks for the value of k plus abc, k I know is 6, a into b into c will be 3 into minus 1 by 2 into 1 by 3, right? 3 into 2 will cancel out with 6, right? Sorry, so 3 will cancel out with 3, so you'll end up getting 6. You'll end up getting 6 minus half. That's 5.5. Right? That's option D. None of these options is the correct one. Right? Okay. So this was an example illustration of how you can use the factor theorem to factorize and then answer a question that involves a cubic or a higher order polynomial. Right? I hope it's clear to you guys. Right? Here's a different variation of higher order polynomial. Right? I'm given an expression in x, and I'm told that this expression has positive real roots, right? Find the value of a minus b, right? Now think about it. If you have positive real roots, then you're multiplying them with each other. Those roots, x minus a into x minus b and so on and so forth, will all get multiplied to give me this expression, right? What do I see? X power 4, coefficient of x power 4 is 1. Constant term must be 16, right? And you have alternating coefficients. Right? You have minus 8 followed by a followed by minus b and then finally 16. Well, to be honest, this question, we haven't learned enough in today's lecture to be able to solve this question. So I will give you a hint. I won't exactly solve it. The hint is that you will tend to use the logic of sum of roots and product of roots, right? How do I do that, right? Well, this expression is supposed to have 4 roots. So let's say alpha, beta, gamma are the roots, right? Then by using, this logic, alpha, beta, gamma and sigma, the product will be equal to 16 upon 1, right? The constant term upon coefficient of x power 4 will be the product of roots, right? Alpha, beta, gamma, sigma must be 16. And similarly, if I go with the first coefficient divided by this ratio, right, minus 8 upon 1, right, will in fact be sum of roots 1 at a time, This is called the sum of roots one at a time, which means it will be alpha plus beta plus gamma plus sigma, right? So you have 4 values which give me a sum of minus 8. I'm already thinking minus 2, minus 2, minus 2, minus 2. But do 4 minus 2's become a product of 16? Yes, they do, right? And so this question unfortunately won't be solved by the remainder theorem or factor theorem. So we'll in fact directly say, okay, 4 numbers whose sum is minus 8 and product is 16 must be, right? The roots must be alpha, all of the roots equal to minus 2. There in fact will be 4 equal roots here, which will be minus 2. So which means this expression should be x minus minus 2. That's x plus 2 to the power of 4. So you can expand it, right? X square plus 4 plus 4x, again whole squared, right? A plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. What do I get? I get x cube plus 8x square plus 24, sorry, x cube plus 8x, sorry, I'll get x power 4 plus 8x cube plus 24x square plus 16x plus 16. Right? So now all I need to do is compare, x power 4, yes, there is that term. 8x cube, well, it's supposed to be minus. Oh, sorry. Here's the silly mistake, right? Product of roots is also 8. Both are positive. So the root will be actually plus 2, which means the factor will be x minus 2. So x square plus 4 minus, 4x. So x power 4 plus 16 plus 16x square plus 8x square minus 16x minus 8x cube, right? So there you go, x power 4 minus 8x cube. Let me write it again. X power 4, yes, that was there in the original expression. Minus 8x cube also there in the original expression. But besides that, now I have plus 24x square, right? That wasn't there in the original expression, which means that a should be equal to 24. Right? Similarly, b, the coefficient of x, in this case I'm getting minus 16x, right? Plus 16. So clearly minus 16 will be the value of b, right? So what is the value of a minus b? 24 minus 16 is in fact equal to 40, right? So this is clearly none of the mentioned option choices, right? So there you go. A clear illustration of how we can use sum and product of roots, which we will learn later on. I will talk about this in detail, but if you already know it, here's how I solve this question, right? Before we go on to the next problem, remember to check out the Unacademy app. There's tons of things to try out over there. Special classes are where, educators such as me create live free lectures, right? Which you can join and try to get a hang of how the platform works, how well you can learn on the Unacademy app. And these lectures are not limited to just me. There are many educators who create such live lectures, right? And then the advantage of studying on an app like Unacademy is that you get, specific topics we will create, educators will create and do a lot of sessions that are called marathon sessions, right? These marathon sessions basically involve long sessions that will deal with a particular topic. So make sure that you get all notifications, download the app, join our channel, subscribe to our channel, and make sure that you join our Telegram, follow our Telegram link as well. Right. Okay, so now that we've done one portion of this session dealing with polynomials through the remainder theorem, let's also deal with the other part of today's session, which is to deal with polynomials by using algebraic identities. Right? Let's use algebraic identities to solve questions. Okay, what kind of inequalities? Well, some of the ones are fairly straightforward. A minus b, a plus b whole square. Obviously is a square plus b square plus 2ab. I'm not going to write it. I'm going to leave it for you guys to figure it out. Right? A plus b whole square. You have a minus b whole square. Again, a square minus b square. Three very, very basic identities. I'm not going to even take the trouble of writing this down. In the previous question we used a plus b plus c whole square. That's a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Right? And if indeed a or b or c, one of them or many of them are negative, no problem. In the expression you just multiply them with negative values. Okay. Other identities include a plus b whole cube. I hope you remember this. A cube plus b cube plus 3ab into a plus b. Right? Just like a cube minus b cube will then be a cube minus b cube minus 3ab into a minus b. Right? So it's a okay, that's an expression for a minus b whole cube. From here you could derive expressions for a cube plus b cube and a cube minus b cube also, right? I hope you guys already remember it. A cube plus b cube is a plus b into a square plus b square minus ab. Just like a cube minus b cube will be a minus b into a square plus b square plus ab. Right? So those are important, very useful identities. Right? Now here's another unique identity. It's a very atypical identity. A cube plus b cube plus c cube minus 3abc will be a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Yeah. Okay. That's the identity there. Right? There are some other useful things also. Like for example, if you have an expression p that looks like a power n plus b power n, right? Then the property is that if the power is odd and an integer value, then p will be divisible by a plus b. Right? As long as it's an odd power like a plus b, a cube plus b cube, a power 5 plus b power 5, that expression will be divisible by a plus b. But if the power is even, that will not be true. Right? Remember that. Similarly, if you have a power n minus b power n, right, this expression is always divisible by a minus b, right? Obviously for integer values of n, right, it will always be divisible by a minus b. However, if n is even, if the power is indeed even, then p is also divisible by a plus b, right? So a power n minus b power n can be divisible by a minus b as well as by a plus b. It will be divisible by a minus b if, it doesn't matter what the power is, but it will be divisible by a plus b only if the power is even. ठीक है, ये rule याद रख लेना. Like for example, let's look at some questions involving identities. Right? You look at this expression and immediately you will probably start thinking a cube plus b cube, right? So numerator 55 cube plus 45 cube can be written as a plus b into a square plus b square minus ab. That's 55 into 45. Right? But what is the denominator? Lo and behold, it's exactly the same expression, right? 55 square plus 45 square minus 55 into 45, right? And you can see the numerator and denominator, this term will get cancelled out. So what is my answer? 55 plus 45, that's option A, 100, right? An absolute sitter. This indeed is the kind of question that you can get even in competitive exams like the CAT. Okay, here's another one. And this is in fact a previous year CAT question, right? 55 cube plus 17 cube minus 72 cube. Can you tell me what is n divisible by? Let me give you a minute for this question to sink in. 55 cube plus 17 cube minus 72 cube. What I can do is, in this case, I can write 72 as 55 plus 17 whole cube, right? Which means this will expand into 55 cube plus 17 cube. But it will also give me plus 3 into 17 into 55 into 3ab into a plus b. So 55 plus 17, right? So this is in the, if I substitute this in the expression, I can see 55 cube, and remember this is negative of this, right? So my answer will be 55 cube plus 17 cube minus this whole expression, 55 cube plus 17 cube plus 3 into 17 into 55 into, how much is this, 72. Right? So 55 cube and minus 55 cube will cancel out. 17 cube and minus 17 cube will cancel out. What I'm left with will in fact be, okay, and a plus b whole cube, what I'm left with is minus 3 into 17 into 55 into, and I can now see this is 5 into 11, right? 72's, 2's and 3's, so no point. So this will be divisible. Is it divisible by 3, 7? Yes. No, it isn't. Right? Ruled out. 3 and 13? No, I can't see 13 here. 7 and 17? I can see 17, but I can't see 7. Right? Ruled out. 3 and 17? Absolutely, I can see both these factors. So there you go. Answer option D. It's divisible by both 17 and 3. Here's another one. Also based on this property that we've learnt some time back, right? Does it come to your head? I'm asking you to infer something about 5 power 6 minus 1, right? So I can write this as 5 power 6 minus 1 power 6, for example, right? A power n minus b power n is always divisible by a plus a minus b, right? So in this case, this will be divisible by 4. Useless information. Doesn't really help me. So, and since power is even, it will also be divisible by a plus b, that's 6, right? Equally useless, because I don't see that in the option, right? So clearly I need to rejig this expression, right? Well, if at this point you still haven't figured out, pause the video and then try it yourself and then watch the solution. I'm going to solve this for you guys, right? So 5 power 6 can be written as 5 square ka whole cube, na? Similarly, minus 1 cube ऐसे लिख सकता हूँ, which means this is basically 25 cube minus 1 cube. So a cube minus b cube, where the power is an integer, will always be divisible by a plus b, a minus b. So this is divisible by what? 25 minus 1, that's 24, right? Is that useful? Well, no, not really. Okay, how else do I write this? I can also write this as 5 square ka whole cube, sorry, 5 cube ka whole square minus 1 square. I can also write it this way, right? Does that help? What is 5 cube? 125. So I'll get 125 square minus 1 square will be divisible by what? A minus b and a plus b. So it should be divisible by 125 plus 1, 126, and 125 minus 1, that's 124. Yeah, okay. Is that helpful? Well, look at 126. This is 6 into what? 6 2s are 12, 6 1s are 6 into 21. So basically it contains 7. Okay. Similarly, 124 can be written as what? 4 into 31. There you go, 31. Exactly what I was looking for. Option B will be the correct choice, because I can see it's divisible by 124, which itself is a multiple of 31. Right? And that's how I solve this question. Right? A similar approach can be used in this particular question. Right? 7 power 6n minus 6 power 6n. Remember, I'm going to solve this. So if you want to try this out yourself, pause the video at this point, try the question yourself and watch the solution. Right? The trick to solving this question is to, you want to rewrite this in many ways, right? So this itself will be divisible by, since the power is even, by a minus b and a plus b. So it will be divisible by 1 a minus b and 13 a plus b, right? But then I don't seem to spot 13 here, right? So useless. So instead, I can write this as 7 square to the power 3n, right? Now I'm going to write 7 square is 49. So 49 power 3n minus 6 square, 36 power 3n, means that this will be divisible by a minus b, right? So divisible by what? 49 minus 36, that's in fact 13. Yeah, as good as that is, useless for me. Or I can write this as 7 cube 343 minus 6 cube 216. So 7 cube power 2n minus 6 cube power 2n. Now you have the power as even. Since power is even, it will be divisible by both. Right? So it should be divisible by a minus b. Right? What is the difference? 7. 127 is the difference. And by their sum, what is their sum? Well, that's 559. Right? So this is divisible by both 127 and 559. Correct answer should be option D. Right? Both 127 and 559. Right? So again, very, very common to use, algebraic identities, to use, these divisibility rules that are also derived from algebraic identities, right? Very, very common to get questions like this. Here's another one, right? Very, very simple. In fact, such a simple one, only if you know the identity, right? You look at this expression and you're thinking, okay, do I remember an identity for A, B and C? Yes, A cube plus B cube plus C cube minus 3ABC is given to me as, can be factorized as A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Right? That's the way that you can expand it, right? Now you're given that this and this are equal, right? This means left hand side is 0. That's given, right? Because from this step I can conclude that the left hand side is 0. So RHS should also be 0, right? But in the RHS, A plus B plus C cannot be 0, right? This part cannot be 0, which means this part must be 0, right? So A square plus B square plus C square minus AB minus BC minus CA must be equal to 0, right? Now what is the question asking me? It's asking me for the value of A square plus B square plus C square. So I want this. Clearly that should be equal to AB plus BC plus CA, right? Let's hope that that's given in the expression, in the options. Yes, that is option A, right? So there you go. That's how a simple identity, foreknowledge of that identity helped me crack this very, very simple problem, right? Okay, here's another interesting question that uses identities, right? Can you guess what identity we're going to use here? The denominator gives you a big sort of gaping hint at that. Well, if you haven't already figured it out, let me tell you. Right? Since the power is 1/3, I'm almost guessing that I should cube it, right? So let me rewrite this, right? A cube plus B cube or A plus B whole cube is what I'm guessing, right? But I can rewrite this expression denominator as 3 power 1 by 3 whole square, because that will be 3 power 2 by 3 or 9 power 1 by 3 minus, so instead of that I'm going to say plus 1 square minus 3 power 1 by 3 into 1. Right? Think about this as A, think about this as B. So this is A square, this is B square, this is minus AB. Right? Do I remember an identity that has A square plus B square minus AB? Yes, that's A cube plus B cube. What is that equal to? A plus B into A square plus B square minus AB. Right? So let's substitute A as 3 power 1 by 3 whole cube, B as 1 whole cube will be equal to 3 power 1 by 3 plus 1 into 3 power 2 by 3, that's 9 power 1 by 3 minus 3 power 1 by 3 plus 1. Right? Exactly what we want. So this I already have. But what is the LHS? That's going to be 3 power 1. 1 by 3 into 3 is in fact 3 power 1 plus 1. Right? So this becomes 4. This is the left hand side. So this means that 3 power 1 by 3, right? Remember what you get is 4 equals 3 power 1 by 3 plus 1 into this other thing, right? 3 power 9 power 1 by 3 minus 3 power 1 by 3 plus 1, right? If you bring this to the denominator, that gives you this, that will create this expression, right? So 4 upon blah 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 will in fact be left with 3 power 1 by 3 plus 1, which means the answer is option B, right? I hope that you guys are understanding. If you haven't already figured out by yourself, I hope my explanation or my approach sort of tells you how to get to the answer very quickly, right? Now, besides looking at these identity based questions, I also thought I'll throw in a few miscellaneous problem types, 1 or 2, just before we close. Right? Here's an expression in X. You can see it's a recursive expression. In recursive expressions, you basically try you basically try to identify a portion of the expression which is itself, right? So for example, if you consider this portion, isn't this the same as the expression itself? If that be the case, you can solve it by rewriting this as x would then be equal to square root of 1 plus itself, that is 1 plus x, right? So square it, right? X square will be equal to 1 plus x, which means my quadratic will become x square minus x plus minus 1 equals 0, and you can go on and solve it, right? Those of you who know quadratic equations and how to go about solving it, I'm sure you'll get an answer to this question, right? But remember, there's a trick involved here, right? Remember that x is denoted as the square root of 1 plus something, right? So since it's a square root, but before the square root there's a positive sign, remember that x is in fact a positive square root, which means x cannot be negative. X must be greater than 0, right? This is a condition that must be met. So when you solve it and you get roots, ignore anything which is negative, right? Similar question, another form. I'm not going to solve it. I'll leave this one for you guys to try yourself, right? Obvious part, look for some portion within the expression that denotes itself, right? So you have root of 4 plus, right? Where do you see root of 4 plus? There you go. 4 plus root of 4 minus, that sounds like a deja vu, right? So this is where it starts repeating. So x would then be written as root of 4 plus root of 4 minus x, right? Clearly I need to square it twice, right? Squaring it once, x square will be 4 plus root of 4 minus x, which means x square minus 4 the whole square will be in fact equal to 4 minus x. This will clearly become a degree 4 equation, right? In fact, at this point I'm probably thinking, is it really worth solving at all? I'll leave that judgment to you. To my mind, it's a question which which you can either solve, or better still, you can expand this, get the equation and use the concept of sum or product of roots, right? You're given a root, right? Clearly. Achha, one more point here. Remember that in general with equations, irrational or complex roots will always occur in conjugate pairs, right? So as long as you have, let's say, option B you're trying out, right? You can almost assume that if option B is a root, then option C must also be a root, right? Or maybe not. Maybe it will be minus root 3 minus 1 by 2, right? But its conjugate pair must exist, must also be a root, right? So that, why am I telling you this? So that once you have a pair of conjugate roots, you'll probably add them and check the sum of roots, or maybe multiply them and check the product of roots, and match it with the given expression, right? That could be one way of solving this particular question, right? Another recursive question, right? You can see here is where, right? This point is where it starts to resemble itself, right? So substitute this with y and then solve the question, right? Another type, last question I'm going to discuss here today is called, this kind of an expression. You can see this, kind of expression is a symmetric expression, right? Or in fact, I'll call it a cyclical expression. Why is it called a cyclic expression? Because if you take A and you replace it with, if you replace A with B in the entire expression, then you'll see that the expression remains unchanged, right? That kind of a equation or expression is called a cyclic one, right? Now, why is this useful to think about it as a cyclic one? Well, in cyclic expressions, more often than not, A, B and C will be equal, right? So the moment you know it's a cyclic expression, put A equal to B equal to C, right? What does that do? If you put A, B and C as equal, this will become A upon A plus A. It will become half, which means R is equal to 1 by 2, right? So all options which contain 1 by 2, which don't contain 1 by 2 can be ruled out, right? That leaves you with A and C, right? Okay. But that's the problem with, this kind of a inference, that it still doesn't narrow it down enough for me. So I'll need to somehow solve this question, right? So the way that I solve this question is that if A by B plus C is R, then consider each of them and multiply, right? So you will get A as equal to RB plus RC, just as you will get B as RC plus RA and C as RA plus RB, right? And what happens if you add all of these? You'll get A plus B plus C on the left hand side, but notice on the right hand side RA, RB and RB occur twice. RC also occurs 2 times, RA also occurs 2 times, which means this will become 2 times RA plus RB plus RC, right? And if you bring all of it on one side, then